Hi everybody, I'm here to go over the review sheet with you. So let's look at the first question. First question tells us to translate the ordered pair 1, -4 according to the rule -1, 5. We could just add, we could add -1 plus 1, which would give us 0, and add 5 plus -4, which would give us 1. Translations are all about adding. The other thing we could do is go to the point 1, -4, and if you notice, by the way, over here I've color-coded all of the ordered pairs that we're going to be transforming. So we're going to go to the purple point. We could just take that point and move it on the graph. The translation -1, 5, -1 for x means we go to the left one, and 5 for y means we go up 5. 1, 2, 3, 4, 5. That puts us right here, which is where we found out we were supposed to be 0, 1. For the next question, get a thinner line here. The next question, it tells us we're going to be reflecting in the x-axis. We'll take the order pair 5, -7. That's the red point. If we reflect the red point in the x-axis, we find the distance to the x-axis and duplicate that distance over here. Well, if this ordered pair happens to be 5, -7, that means the point is 7 units away. We're going to duplicate that and go 7 units above, which would put us right here. And that would be the point 5, +7. So let's write that down. Oops, let's make that look a little neater. That's the point 5, +7. And if you compare the before and after, the only thing that's changed from here to here happens to be the y value. When we reflect in the x-axis, just the y value changes its sign. For the next question, we're reflecting in the y-axis. That's question number 3. Look for the yellow point. We're going to reflect that in the y-axis, which means we would count the spaces to the y-axis. It happens to be 2 places away, so we duplicate those 2 places on the other side, bringing us to the point -2, -1. If you compare the before and after, take a look. The only thing that's different from the before and after is the x value changed its sign. When you reflect the y-axis, the x value gets changed. In question 4, we have a capital R. Capital R means we're going to rotate. We're rotating 90 degrees, which means we're going to be going counterclockwise. We're rotating 90 degrees, taking the point -3, 5. So find the green point. You can turn your paper to the left or counterclockwise 90 degrees. I'm going to use the rule since I can't turn my paper. The rule for rotating 90 counterclockwise is -y, x. Now, it may look confusing, but it's really not so bad. I'm going to set up my parentheses. That means I take the opposite sign of the y value and I move it to the front. That becomes a -5 and it moves to the front. The regular x moves to the back. So the regular x was -3. That just moves to the back. The ordered pair becomes -5, -3. So that means that that green point would be 1, 2, 3, 4, 5, 1, 2, 3. That would end up right about here when I rotate it 90 degrees. And if you turned your paper, I'm sure that's where it ended up. For number 5, we're also going to rotate. We're going to take the blue point, which is up here in the right corner, and we're going to rotate it 180 degrees, or turn your paper upside down. I'm going to use the rule, since I can't turn my paper upside down, and the rule is very simple, just to change the sign of each coordinate. We have -x, -y. We'll negate both. We have 8, 11. So when I rotate it 180 degrees, it's going to become -8, -11. Just like that. So -8 is over here, and -11 would be 1 point off the grid. So it went from the top right to the lower left. In number 6, we're reflecting the point -3, 6 in the line y equals x. So the point -3, 6, notice it's the orange point, and that's right here. First, we need to realize what this line looks like. The line y equals x. For that line, that's the line, a diagonal line passing through the origin. And it passes through these points here. If x is 1, y is 1. If x is 2, y is 2. If x is -1, y is -1. Whatever x is, y is. Y is the same as x. So if we connected these, I'm just going to connect them with a dotted line. That's what the line would look like, y equals x. We're going to take that ordered pair, -3, 6, -3, 6, which is up here in orange, and we're going to reflect it in that line. If we found the distance, which is really hard diagonally, and we duplicated it over here, it's going to land somewhere over there. So the rule here, we really need to remember the rule for number 6 and actually for number 7. The rule is just to switch. I'll write that down. When I reflect the line y equals x, since y is the same as x, basically you can switch them around. Just take your ordered pair and switch the coordinates. Y becomes x, and the x becomes a y. So that becomes 6, -3. 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 3. Oh, I'd already plotted this before, and I didn't realize that. So this orange point, when I reflect it in the line y equals x, this distance duplicates over to here. For the next one, we're going to reflect in the line y equals -x. That line is just about exactly the opposite of the yellow line. So we'll sketch that in. Sketch that one in blue. It goes through 0, 0, and it goes through these points. It's a diagonal line moving downwards through the origin. I'll connect them with a dotted line. And now we're going to be taking the ordered pair 9, -5, which is down here, and reflecting it in this line, which I didn't actually make long enough, so let's make it a little longer. This line would keep going. Now we're ready. So I'll be reflecting that line, that point in this line. I'd find the distance from here, line, and I'd go over here the same distance. And let's do just that. So the rule here, since it's y equals -x, it's almost like y equals x. Except, since there's a negative, not only am I going to switch, but I'm going to negate as well. So I'll write it down. We're going to switch and negate. I don't want to confuse you with the word negate, but that just means change the signs. Let's take a look. The -5 has to move to the front and change its sign. It becomes positive. The 9 has to move to the back and change its sign. It becomes negative. The ordered pair then is 5, -9. 1, 2, 3, 4, 5, all the way down to -9 right here. And it makes sense. If I look, this distance was duplicated over here. And there we have it. Here's the beginning of the review sheet. Let's move down. In question 8, it says if m prime, which is -7, 1, is the image of m after a translation of 1, -4, what is m? Well, we have to work backwards a little bit here. They gave us the image. They want us to find the pre-image. I'm going to set myself up here. I'm going to start with m, which is what I'm looking for. I'm going to call that x and y. I don't know what it is, but I do know they transformed it, and it became -7, 1. And I know the transformation was 1, -4. So t, 1, -4. So if I set myself up, let's get a different color here. They took x and they added 1. They did x, they added 1, and they came out with -7. Then if I set up my y equation, they took the y and they subtracted 4, and they came out with 1. Now you just need to solve both equations. If you solve both of those equations, then you come out with the ordered pair. If I subtract 1 to both sides, I end up with -8. And if I add 1 to both sides, I get 5. So my original ordered pair for M was -8, 5. And you can always check that by taking -8, 5 and going through the transformation to make sure you get -7, 1. Let's move on to number 9. The point -5, 7 was translated to 8, 5. What was the rule used in the translation? We're going to set ourselves up like we did before. We're going to start with this point, -5, 7. We know it became 8, 5. It's the same setup. And up here, I know it was translated. The only difference is that instead of having numbers here, I'm going to call it XY. There's always going to be an XY. Notice up here I had an XY. That's what I was looking for. Here I have an XY. That's what I'm looking for. But the process stays the same. I'm going to make an equation. They started with -5. They added x to -5. And they came out with 8. Then they took 7, added y, and they came out with 5. We have 2 equations now to solve. If I added 5 to both sides, for x I'm going to get 13. And if I subtract 7 to both sides, for y I'm going to get -2. Actually, most kids do just this. Is that what I'm looking for? Was I looking for an ordered pair? No. Let's take a look. I just did what most kids did. I'm looking for the rule. So the rule is the x move was 13 and the y was -2. No parentheses. It's not an ordered pair. It's a rule. So don't go rule happy. It's a rule. Take a look back at what you set up in the beginning. Don't always write things in a rule. Up here we needed a rule, not in this one. So just be careful. That's a common mistake. Which of the following has rotational symmetry? Rotational is what it sounds like, rotating, turning. Rotational symmetry, if something has symmetry, that means that perhaps one half looks like the other half, one side looks like the other side, but now we're talking about turning. A figure has rotational symmetry if you can rotate it and it looks the same as it started out. So this triangle here, can you picture rotating it somewhere less than 360 degrees, which is a full turn, and having it look exactly like it did before? If you need to, you can turn your paper and see if it looks exactly as it did upon certain rotations. 30 degrees, 60 degrees, quarter turn, half a turn. How about the X? Or how about this, which looks to be a trapezoid? Or how about this interesting shape? Well, as it turns out, this figure has rotational symmetry around this point. You could turn it 1, 2, 3 times. Of course, you could turn it 4. That would be 360. But you could definitely turn it 3 times. Try that with your paper. If you rotate your paper, you won't even know that you turned it because the X will still look like an X. With this, if you put a point in the middle and you rotate it around that, if you turn it upside down, try that with your paper, it's not going to look the same. It will completely look upside down. And with this last shape here, over here, oops, now this is getting stuck. So if you envision the center point right here, this can be turned, I'll let you guess, 3 times. 1, 2, 3 would be a full 360. So you could turn it full times and have it 2 times and have it map onto itself. We have this one here, and this one here that have rotational symmetry. So 1, 2. Not this one, and certainly not this one. Let's go to the next page. Number 11. In number 11, it says, given triangle ABC, and they give us the coordinates for A and for B and for C. Get a thin line here. Graph and label triangle ABC, and then in part B, we are to reflect the triangle in the x-axis to get A prime, B prime, C prime. And then we're going to translate A prime, B prime, C prime to get A double prime, B double prime, C double prime. So we're doing a composite transformation here. I don't know why the mouse is sticking. I'm sorry about that. So let's graph and label triangle ABC. You've already done that on your paper. I need to move this down a little bit. All right, so A is negative 2, 2. Let's use purple. Make sure you label your order pairs. A, B, and C. I'll sketch it freehand just like you guys sketched it freehand. It would be better if we used a ruler. Just going to sketch it freehand. There we go. Now, to reflect the x-axis, if you remember from the previous page, we said that when you reflect in the x-axis, you just change the sign of y. You certainly could reflect in the x-axis. You could count. You could count down to, for A, you could find the distance, count to, down to. You could count and count, count and count. I'm just going to change my order pair since I have to write them anyway. Reflecting the x means I change y. I'll have negative 2, negative 2, 1, negative 4, and I'll have 2, negative 1. So I'll graph these. Let's do that in green. And make sure you label, that's A prime. B prime, and C prime. Carefully connect them. It should look like it's been flipped over the x-axis. The next one, this was the green one. The next one we have, we'll do in blue. We're supposed to translate the green one by negative 2, 3. So we can either do it by adding. Where's my mouse? Lost my mouse again. Hang on, folks. I'm missing a mouse. So we're going to translate this green triangle by negative 2, 3. I can either take each ordered pair and go to the left 2 and up 3 and plot it, or I could do it by adding. I would have to do negative 2 minus 2 and 2 plus 3. 1 minus 2 and 4 plus 3. Sometimes the translating is just easier to do on the graph. This means we're going to go to the left 2 and up 3. Let me get a different color. Let's do red. Left 2, up 3. Left 2, 1, 2, 3. A double prime. Left 2, 1, 2, 3. Gets a little tricky when they overlap. Left 2, 1, 2, 3. B double prime. And notice there is a space for us to write down the ordered pairs. We will have to make note of them. 1, 2, 3, 4, negative 4, 1. And for B prime, we have negative 1, negative 1. That was negative 1, negative 1. And for C prime, we have 2, we have 0. Did I mark these right? A double, I think I lost track of who was who. This was A double, 2, C double. Oh, this one was C double, wasn't it? 1, 2. Oh, you know what? This one was C double. Silly me. I'm going to have to fix that. Hang on. Quick fix. I realized that one I had 2 A's. Let's go back and fix that one. The red one. So this guy is C double prime. Okay. So C double prime is 0, 2. You can double check and make sure they match. For instance, the 2, 1. 2 minus 2 is 0. And 1 plus 3. 1 plus 3 should be, oh no, not 1. You're adding it to here. 2 minus 2 is 0. And negative 1 plus 3 is 2. You can check with each of these. 1 minus 2 is negative 1. Negative 4 plus 3 is negative 1. Negative 2 minus 2 is negative 4. Negative 2 plus 3 is positive 1. So that all checks out. And we have our graph. Completely done and labeled. For number 12, draw in the line of reflection for each graph. Well, you can pretty much see, I think, where it looks like it was folded, where is exactly in the middle, or where it looks like the middle. It looks like a horizontal line. To find exactly the middle, you locate 2 corresponding points and then find halfway between. For instance, this point here and this point here. They are 2 units apart, so halfway would be 1. If you doubt yourself and you're not sure, find another 2 points, like this point here. That's not an easy point to locate. Perhaps this point here with this point here. Count how far apart they are. 1, 2, 3, 4, 5, 6, 7, 8. Halfway would be 4. 1, 2, 3, 4. And that lines up with this also. So if I were to draw in the line of reflection, right there. Not the neatest looking line. Let's see if we can make a nicer looking line. Let's get a line. There we go. That's much better. There's the line of reflection. Over here, it looks like it's right down the middle. In fact, right here. So I'm going to use this for my line of reflection right here. Yep. And if I want to double check, get a pen. This point corresponds to this point, and they're 2 units apart, and 1 is right in the middle. Moving right along. Let's go to the next page. On to 13. Write the sequence of transformations shown in each graph. Well, A is the original, and A prime is the image. It definitely looks like it's been turned upside down, would be my guess, because if I look at this figure, it's leaning to the right, slanted to the right, and this one is slanting to the left. So something happened, either a reflection or maybe a rotation. When they say sequence, that implies that perhaps more than one thing was done to get it. We don't have to be very specific. You don't need to give us how many degrees if it was rotated. You don't need us to give us the line of reflection. Just in general, 2 things. Same thing here, from A to A prime. One option for this one is that A was translated down here, which would make it look something like this. And then reflected in the y-axis. So I think a translation followed by a reflection. That's my answer. Translated followed by a reflection. There are various other answers. It could perhaps be a reflection followed by a translation. You could first reflect it in the y-axis and then translate it. Could you be specific and tell exactly how? Absolutely. You could translate it 1, 2, 3, 4, 5, 6, 7, 8 places down, and then you could reflect it in the y-axis, or reflect it in the y-axis and then translate it 8 units down. Over here we went from this to this, and notice A prime is upside down. So I would venture to say it's, could it be a reflection? It could be a reflection. It would end up 1, 2, let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It would be upside down, so it could be a reflection. Followed by 1, 2, 3, 4, 5 down, 1, 2, 3, 4, 5, 6, 7, 8, 9. Followed by a translation down 5 and the left 8. So that would be T, negative 8, negative 5. Could it be a rotation? Absolutely. It could possibly be a rotation. You could rotate it counterclockwise, 180 degrees, and then a translation after that. So after you rotate it, you're 1, 2, 3, 4, 5, 2, 3, 4. So you'd have to rotate it over 1 and then down. Just two possibilities. Point symmetry. Point symmetry, that's when you can rotate a figure exactly 180 degrees and have it look just like it originally did, or map onto itself. If I turn this trapezoid upside down, will it look like the same trapezoid? No. If I turn this upside down, will it look exactly the same? No. This one, if you turn it upside down, it will. This point will end up in the left, and this curve will end up here. So this one has it. Will this end up being the same? If you turn it upside down, take your paper and turn it upside down. Will it look the same? Yes, it does. So this has point symmetry as well. Reflect the figure in the given line using a ruler. So you're going to take your ruler, and you could basically measure the distance from A, the perpendicular distance, that is, how far A is to the line, and then you're going to duplicate that distance over here. So A prime would be somewhere about here. You're going to take your ruler, straight edge, and you're going to find the distance from W to that line, and then you're going to duplicate that distance, and that's going to be W prime. Put this down. And you take L, and you find the distance from L, perpendicular distance, that is, to the line, L prime, and H, find the distance from H to the line, then over to here. Mine is definitely a rough sketch. I'm not measuring with the ruler. Yours should come out much better than mine. I think I'll do mine in a different color. Let's do green, so it stands out. There we go. Something like it. L prime, prime. There you go. Something like that. Looks like it was reflected. And I think that's the end. I think that just might be the last of it. Let's double check. See if I have another page for you guys. Oh, wait, there is more. Okay. Little more to go. We're almost there. We have 16. Translate the figure according to the vector shown and label the image properly. Well, the vector is telling us to go from here to there. I know it's going up to the right because the arrow is at the top here. So we need to move up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and to the right 1. So up 5, right 1. I need to do that with each corner. 1, 2, 3, 4, 5. To the right 1, T prime. 1, 2, 3, 4, 5. To the right 1 is R prime. You do that for each vertex. Then the figure should look exactly the same as it did before. It was a rectangle before, it should still be a rectangle. There you go. The next one, draw a vector to represent each translation shown on the graph. Well, I would figure the distance from here to here and the direction. To go from this bottom point to the bottom point, this is A, this is A prime, I need to move down 1, 2, 3, 4, and to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can draw my vector anywhere as long as I go 1, 2, 3, 4 down and 9 to the right. 1, 2, 3, 4, 9. So I need to connect that with a line. There we have a vector. Here's my vector. Just make sure you can tell that those are the arrows. The next one, B to B prime. Pay attention to the order in which you have to draw the vector. B starts here, B prime is here. You either connect the lower right to the lower right corner or the lower left to the lower left. I'm going to go lower left to lower left. I would have to go up 2 and to the left 1, 2, 3, 4, 5. So up, oops, up 2, 1, 2, 1, 2, 3, 4, 5. So I'm going to do that somewhere on the graph. Start here, 2. A line. You need to make sure your arrow points in the right direction. It's a little hard to see the arrow, so I'm going to add a little arrow on it. So we know which is the beginning, which is the end. There we go. There you have it. There's the whole review sheet. Well, I hope that helped. You can watch this as many times as you like. Good luck studying.